Hello Math 30-1. Today we are going to look at factorial notation and permutations. So we're actually starting now to get into the permutations part of the permutations and combinations unit. So to start off, we're just going to figure out what does factorial notation mean. So here, factorial notation is normally when we put it like this. So 6 with this exclamation mark, like it's yelling at you, means 6 factorial. Okay? So that it could be written out like this. So this here means this. Okay? So without using a calculator, try and calculate what is 4 factorial. Well, that is equal to 4 times 3 times 2 times 1. 4 times 3 is 12 times 2 is 24. And times 1 is just whatever. Okay? Itself. Now, the next one here is 3 factorial times 2 factorial. So that's equal to 3 times 2 times 1. Then we have to multiply that by 2 factorial, which is 2 times 1. Okay? I multiply these together. This is the same as 6 times 2, which is 12. All right. So, now we're going to go on to this other part here. Okay? And it says express 5 factorial as a product in 4 different ways. So, here's one way. We could go 5 times 4 times 3 times 2 factorial. Because 2 factorial is just 2 times 1. Okay? This here is 2 factorial. Now, 5 factorial, we could go 5 factorial, or sorry, 5 times 4 factorial. That's another way of doing it. Or we could go 5 times 4 times 3 factorial. And I could even go 5 times 4 times 3 times 2 times 1. There's another way of writing out. All of these things mean the same thing. All of these mean 5 factorial. Okay? So now it says complete the following. 12 factorial is the same as what times 11 factorial? Well, 12 times 11 factorial. Okay? 8 factorial is the same as what times 6 factorial? Well, we need 7, and then we'll have to multiply by 8. So it's 8 times 7 times 6. Then the rest of 6 factorial is 5, 4, 3, 2, 1. So really, this is 8 times 7 times 6 times 5 times 4 times 3 times 1. So we just write it out like that. Now, factorials can also be expressed as a quotient of factorials. So here we have 5 times 6 times 4. That's it. Now we're missing the rest. So really, we have 6 factorial, I'm going to say, is on top. Okay? And then we're missing the rest here. 3 factorial is being divided. Because basically what we have, I'm just going to write it over here on the side. What we ended up doing was we have 6 times 5 times 4 times 3 times 2 times 1. And then we're going to divide it by 3 times 2 times 1, which is 3 factorial. And if we do this division, these cancel off, and we're left with just that, which is a neat little thing that we're going to be using quite a bit here in this unit. So this one here, 15, 14, 13, and 12, well, it's 15 factorial all over. Well, we're missing 11 factorial on, so if we divide 11 factorial, that's getting rid of everything from 11 factorial on. Okay? So now without using a calculator, simplify the following. So this one here is going to be 10 times 9 times 8. Because the 7 on is canceled off with the division by 7. So 10 times 9 times 8 is equal to 720. Right? The next one here, well, this one here I'm going to write out as, well, we have 8 times, I'm going to write this all out, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 5 times 4 times 3 times 2 times 1, which we didn't have to write out because I could cancel these off there nicely, right? And then we have the 3 factorial, which is 3 times 2 times 1. So I have 3 times 2 is 6. That cancels off the 6. So I'm left with 54. And that's all we do. Okay? And so now, factorial notation. This is the algebraic thing for it. So it's n terms. Okay? So n multiplied by the term before, which is n minus 1, multiplied by the term before that, which is n minus 2, multiplied by the term before that. So here's an example. If I say n is 15, that's going to be 15 multiplied by n minus 1. 15 minus 1 is 14. Multiplied by 15 minus 2 is 13. So it's a way of counting down. Okay? So, here we go. Now it says complete the following. We have n factorial is the same as n multiplied by n minus 1 factorial. So next one would be n minus 2, then n minus 3, then n minus 4, and so on. Going on forever till we finish. N plus 2 factorial is the same as what times n factorial? Well, we are 2 bigger than n. So we have n plus 2 multiplied by n plus 1, then multiplied by n factorial. Because these are the two, it's 2 more terms above n. Now this one here, we're starting at n minus 4 factorial. Well, n minus 4, n minus 5, n minus 6. So n minus 4 is our largest one. So n minus 4 factorial is my answer. Okay? All right, let's take a look at example 2. It says, simplify the following expressions. Leave the answers in product form where appropriate. Well, if I look at this here, we are going to keep on going until we get n. So it's kind of like what we did on the last page, except now we have algebra. So we have n plus 2, okay, n plus 1, and next would be n. The next one's n, so I don't have to worry about that. This is just going to be n factorial, because it's going to keep on going down, and n factorial. So these will cancel each other off, and I'm left with n plus 2 multiplied by n plus 1. Just like that. Okay? Let's look at the second one here. So we have n minus 2, n minus 1. So which one of these is smaller, n minus 2 or n minus 1? Well, if I put in any number, let's say 10 for n, the top would be 8, and the bottom would be 9. So the bottom's actually bigger than the top. So we're going to start breaking down the bottom. So we'll have n minus 2 factorial. And we're going to keep on breaking down the bottom until we get n minus 2. So we have n minus 1, and then n minus 2. Oh, there we go. It's going to keep on going, so that's factorial. These cancel off. I am left with 1 over n minus 1 as a solution. Let's take a look at C now. So here we have a factorial, but the bottom there's no factorial. So we're going to break down the top so we actually have some things to cancel off. So this is going to be the same. The top is going to be n. Then we have n minus 1. These would cancel off. So what's next? Factorial. So these cancel off. I'm left with n subtract 2. Factorial is my answer. Okay? And there's my answer there. All right. So now let's take a look at class example number 3. So algebraically solve this equation. So we're going to end up, I'm assuming, getting a quadratic formula. So I look at this, which one's bigger, the top or the bottom? I'm saying the top, so we're going to break down the top till we get the bottom in factorial form. So I'm going to start off with n minus 1, because that's one term smaller. Then n minus 2 would be the next term. Oh, that's the exact same as my denominator. Factorial all over n minus 2. Factorial is equal to 42. These cancel. I end up getting n minus 1 is equal to 42. So n squared minus n, multiply the n into both, distributive property, is equal to 42. 42. Make this equal to 0, so I get n squared minus n minus 42 is equal to 0. So I'm going to put in here, we could have, factor this here, I'm going to end up getting n minus 7 and n plus 6 is equal to 0. So my factors could be n is equal to 7, or we could have n is equal to 6. Sorry, negative 6. Now we're going to reject the negative because that one could go on forever. So we're going to just end up having the, since it must be whole numbers, n must be an element of whole numbers, as we know by the definition up here, which is important. N must be a whole number. Okay, so it can't be a negative number. And 0 factorial is always equal to 0. That's something we just have to know, but we'll get to that a bit later. So basically, my only answer here is n is equal to 7. Okay? Our next part here is we're going to learn how to punch these into the calculator. So all we have to do for this is, here's my calculator. I'm going to just go a little bit more. I thought I had enough, but I didn't quite. Okay, so here's my calculator, so we can see kind of what I'm doing. So I want 6 factorial. I just push 6, and then I hit the math button. I'm going to go all over to factorial, which is number 4, and we push enter, and that is 6 factorial. So that's how we do it in our calculator. Okay. Now, to simplify this, we like to evaluate. So for this one here, we could do it 2 ways. We could write it out like that. Is it 720? Or we're going to calculate it a different way, or calculate it like this. So another way to do this on a calculator, we're going to just punch it out. Here I'm going to go 10, and then I'm going to go factorial, so go math, factorial, okay, and I'm going to put this in brackets, okay, so I'm going to go brackets, and I want this to be divided by, and we're going to have 7 factorial times 3 factorial, so I'm going to put bracket, bracket, 7, math, factorial, and we're going to multiply this by 3, bracket, sorry, bracket 3, math, and we're going to go over factorial, and we're going to just close that bracket and push enter, and we end up getting a total of 120. So that's how we could do it into our calculator, and we could just double check using our mental math skills. So 7 factorial and 7 factorial cancel off, and I'm going to end up getting 720 all over 6. 72 could be divided by 6 is 12, so that's 120. So they both work out. You could do these ones here, but we're just going to skip on to that and now get into the meaty part of the lesson, which is permutations. So a permutation is, key thing is down here, is an arrangement of elements which the order is important. So permutation is arrangement in which the order of the elements is important. Okay? So it's an arrangement where the order is important. So we're going to get to some examples here. So let's take a look at class example number 5. Alright, so that over. It says, determine the number of permutations of the letters for each words Regina and Kelowna. So Regina, we have 6 different, I think 1, 2, 3, 4, 5, 6, yeah, 6 different letters, and they could be arranged 6, 5, 4, 3, 2, and 1. And that is technically a permutation. We kind of did this in the last class, which is 6 factorial we learned today, which is equal to 720. Okay? So now we want the permutations of Kelowna. Well, Kelowna, there's 7, which is the same as 7 factorial. We punch that into our calculator, and we could get 5,040. Okay? Now, we're going to go a little bit farther here. So if we have permutations of n, different elements taken from r at a time, which means we're taking amount of permutations, we could have a certain formula. Okay? So an example would be if we're looking at the word graphite, and we say we only want to take 3 letters from the word graphite, how many words can we make with only taking 3 letters from graphite? that would be 8 permutation 3. Okay, so out of 8, we are taking 3, and the order matters. And the formula for that is this here, kind of what we saw. Because really what that's saying is it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But we only want 3 of those, so we cancel those off. Okay, so it's like 8 factorial all over 8 minus 3 factorial, which is the same as this formula here. That just kind of shows you how the formula is made. Now we're going to use that in some examples here. Okay? And then I'll come back to defining 0. But here's the first one. It says, in a region, vehicle license plates consist of 2 different letters followed by 4 digits. Okay? If the letters I, O, Y, and Z are not used, determine how many different license plates are possible by the fundamental counting principle. So if we first did the fundamental counting principle, we have a total of, there's 2 different letters followed by 4 different digits. So we have 2 different letters and then 1, 2, 3, 4 different digits. So my 2 letters, and we can't use 1, 2, 3, 4 different ones, we have 22, 21, and then followed by 4 different digits. So that's going to be, we have 10, 9, 8, and 7, because we could use 0 to 10, and there, and we multiply all of those together, and it's going to give me a total of 8480. Just multiply these together. Okay? Now, if we want to do this permutation ways, it can be a little bit faster. So all we're going to do here is we type in, we're going to have out of 22, we want to permutate, or pick, I like to say, because it's picky, we're going to pick 2. So out of 22 possible, we pick 2, and then we're going to multiply that by, out of a total of 10, we are picking 4. Okay? Now, we could even punch this into our calculator in here. So I'm going to show you again how to do it on the calculator. So if I was to do this, I would push in 20 on 22. Then I'm going to hit the math button. I'm going to go all the way over to permutations, and then we want 2. Enter. Then I'm going to multiply that by, what did we want? We want 10. I'm going to go math over. We want there. Oops, it's supposed to be 10. 10. And we want to pick 4 different ones. And we get the exact same number as if we were to multiply all of those together, which is equal to 2, 3, 2, 8, 4, 8, 0. Okay? So now, here is our last question before I give you the defining 0 part. It says, algebraically solve the equation. All right, so we want to algebraically solve this equation here. Now, I look at this, we're going to have to use my formula from the page before. So we're looking at this formula right here. So we have n minus 1 permutation 2 is equal to 90, which is equal to, we have n minus 1 factorial, okay, n minus 1 factorial, and that's all going to be all over n minus 1 subtract 2 factorial. Okay? So this is equivalent to n minus 1 factorial all over n minus 3 factorial. Okay? We could continue this here. We have n minus 1 multiplied by n minus 2, and then we finally get n minus 3 factorial is all over n subtract 3 factorial. These will cancel off, so we're left with just that. It's kind of like what we were doing earlier. So now we know 90 is equal to n minus 1 multiplied by n minus 2. I multiply these two together. I'm going to end up getting 90 is equal to n squared minus 2n minus 3n minus 2. Okay? Now I'm going to move the 90 over, so I end up getting, or sorry, plus 2. So I'm going to end up getting n squared minus 3n, and here we're going to get minus 88 is equal to 0. So now we're going to factor this here, and if I factor, I'm going to end up getting n minus 11 and n plus 8. And when we go like this, so we have n is equal to either 11 or n is equal to negative 8. But if we remember, we can't have n cannot be a negative number. It has to be a whole number. It cannot be an integer. So this is not an answer. My only answer is that one right there, since n has to be a whole number. All right? Now, just before we finish, here is a little kind of defining 0, why 0 factorial must be equal to 1, which is one of the rules. So if I have any permutation where I'm picking amount, so if I say out of 8 letters, I want to pick 8 of them. Well, if I look at that, that's n factorial, so 8 factorial all over 8 minus 8. Well, 8 factorial is 8 times 8, and then 0 factorial, well, how does that work? You can't divide anything by 0. So this must be 1. So here's an example. If I have 3, pick 3, that's the same thing as 3 factorial all over 3 subtracts 3 factorial, which is 3 factorial all over 0 factorial. But we know if we have 3 things and we want to know how they're ordered, that's equal to just 3 factorial. So this here, 0 factorial, must be equal to